Hi class, I said I would show you how um, you can use a computer to draw the normal curve, and obviously a computer has better graphic capabilities. It's more precise than the human hand. Um, I happen to like Desmos, and if I go to Desmos and type normal distribution, you're going to have two parameters for a normal distribution, because remember we talk about shape, center, and spread, and once we've identified that it is symmetric and bell-shaped, a good measure of center is the mean, and a good measure of spread is the standard deviation. Those two are how we describe our data. That's the same way a normal distribution will be described. You have to introduce the concept of having a mean, right? Let's say 0 for now, so we're centered, and a standard deviation of 1. And you get this curve. Now this curve doesn't look like what you have in your textbooks or the examples we use, but that's because of the scaling and the distorting we use. So notice with my touchscreen, I can actually stretch it, and that looks like what we see in our textbook. We also seem to emphasize from -3 to +3, but the line extends to -infinity and +infinity. So let me try and make that a little bold. So I hope you can see the red line, okay? And so when we look at the standard deviations from -3 to +3, this does look exactly like we see in our textbook or worksheets or handouts or anywhere else. And I also emphasize the little gap here. You see, there is a little gap, but if I zoom out, you won't see it as much. But if you zoom in, it's not actually touching at 3. And it's not actually touching at 4 either. You'd have to zoom in quite a bit, and you can see that there's always a small gap between the curve and the horizontal line. If you want to take advantage of Desmos, you can always hit this button, and it centers you back on the curve. Now, I said this is a center and this is a standard deviation, meaning the gaps between the markings that you're going to be expected to put on your number line. But I also want to show you that if we say the average age at Cerritos College is, let's say, 23.4 years, and the standard deviation after sampling all students, or possibly a sample, the standard deviation might be 3.2. Okay. Notice our curve is no longer present. Well, that's because it's over here. And again, the scaling is off, but we can stretch this by zooming in and zooming out, but also changing our axis. So let me go back here and say, you see, it's still going to have a similar shape if distorted and scaled accordingly to the standard deviation. So now these values here no longer make sense, because they would actually be 23 plus 3.2. And it would be, this is 1 to the right of 23. These are 2 leaps up to the right of 23, and 3 leaps up to the right of 23. And you'll see that they fall again to the right, equally spaced, 23 being the center, and the distance between 23.4. Oh, I made a mistake, but watch. It'll adjust it if I move them all away from 23.4, and I put my center exactly at 23.4. So I hope that gives you an idea of what a nicely drawn, curve looks like using a graphing calculator or a computer. And that's it for now.